So the Ka of a monoprotic weak acid is 4.49 times 10 to the negative 3. What is the percent ionization of 0.174 molar solution of this acid? So what is a monoprotic weak acid? Well, Ha plus water is going to create hydronium ion plus the A minus. Okay? And we're given the Ka, so Ka is going to be the hydronium concentration times A all over the concentration of Ha. Okay? And are we given the hydronium concentration? No. We are given the Ka. So it looks like we're going to have to do an ice table. So we have Ha, we have hydronium, or H plus, it doesn't matter, so I'm going to put H plus for right now, knowing that that is the same as this, and A minus. Okay, I start with 0.174 concentration of Ha. And at the start, I have no hydronium and I have no A ion. So the question is, as it goes towards equilibrium, I'm going to be losing Ha and I'm going to be gaining hydronium, going to be gaining A ion. Okay? And so at equilibrium, I have 0.174 minus X. I'm going to have plus X and positive X here. So that's X times X over 0.174 minus X. And that's going to equal the Ka, which is 4.49 times 10 to the negative third. Now, usually I tend to ignore this negative x because I usually say this number, 0.174, is so much bigger than what x is. But if I look at the Ka is really not that small compared to the 0.174. So I'm not going to ignore the Ka. Okay? So now I have to cross multiply, or multiply both sides by the denominator is how I like saying it. So I have 4.49 times 10 to the negative 3 times 0.174, and that is 0.000781. Okay, and minus, I'm going to write this in decimal form, 0.00449. So that is 4.49 times 10 to the negative third. X equals x squared. Okay? So I need to use the quadratic equation, so I need to get this in quadratic form. I'm going to add this to both sides and subtract this from both sides. So I have x squared plus 0.00449x minus 0.000781, and that equals 0. I'm going to plug that into the quadratic equation, and I'm going to get x equal to 0.0258. 0.0258. Just as a side note, okay, 0.0258 divided by 0.174, and actually that is, okay, 0.0258 divided by 0.174 is 14.8%. Okay, so that is the percent ionization. Okay, so percent ionization is the hydronium concentration over the original concentration. So the HA original. So that is 0.0258 divided by 0.174, and that equals 0.148. We're supposed to multiply that by 100% times 100% to get 14.8%. Okay, and what I was saying on the side note is 14.8% is much bigger than 5%, and because it's much bigger, I can't ignore this. Okay, so the two things are related. This is the answer you're looking for. Because this is greater than 5%, we can't just ignore the x.